Hello and welcome to 1.3.2 Wired and Wireless Networks, Protocols and Layers. Today we're going to start with modes of connection. So as you can see, we're going to be looking at wired and wireless networks. We're going to be looking at Ethernet, Wi-Fi, and Bluetooth. In introduction, all networks work in essentially the same way. A device prepares a data signal to send it to another device, and this is transmitted along cables or wirelessly until it reaches its destination address. This transmission is controlled by protocols, sets of rules that define how data is transmitted between devices across a network. And we'll take a longer look at protocols in a whole set of lessons later on. Data can be transferred from one device to another via cables or wirelessly, and different protocols are used for each type of transmission. For this syllabus, you need to know about wired via Ethernet and wireless via Wi-Fi or Bluetooth. Ethernet is the traditional protocol used to connect devices in a wired local area network. It defines how data should be physically transmitted between different devices using MAC addresses to determine which device the data should be sent to. So if you've forgotten about MAC addresses, this is the physical address of a network interface card, which is usually built into your laptop or desktop or whatever. And this is used to identify that particular device on a local area network. Ethernet also needs to define what should happen if collisions occur in the network. So if data is being sent along the same cable at the same time, packets of data can collide with each other and some of that data could be lost. So remember, although we often call these cables here Ethernet cables, Ethernet actually refers to the software protocol that these cables are carrying. These cables are in fact called CAT cables. What are the advantages of having a wired Ethernet connection? Well, you get a stable connection. It's more secure. What do we mean by more secure? Well, if you have a wired connection, you actually need to be physically in the building and actually plug a cable into your computer to take part in the network. Whereas with a wireless connection, with Wi-Fi, you could actually be anywhere in the surrounding area and still pick up that reception, pick up that signal, and possibly access it. Other advantages include the fact that you get faster data transfer speeds and usually a better signal quality. Wired Ethernet is stable and reliable, whereas wireless connections you can get all kinds of interference. But there are disadvantages to wired connections. It's more expensive to install. Especially older buildings, you have to set up all the cables, drill holes in walls, in floors, route all those cables around the building. That can be difficult. It's also more difficult to add extra devices. Again, you have to lay extra cables. It's all kinds of overheads and costs involved. And also with a wired connection, devices can only be used in one location. You can't pull your laptop around the school or a university or building trailing hundreds of meters of Ethernet cable behind you. It's just not realistic. Moving on, let's have a look at wireless connections, Wi-Fi or wireless fidelity. This is a set of protocols that define how network devices can communicate wirelessly using radio waves. All sorts of devices can make use of Wi-Fi. We've got laptops, tablets, smartphones, video games, consoles, e-readers, all kinds of things. Wi-Fi protocols determine the frequency band and channel that should be used, data transmission rates, and how devices should be authenticated when they attempt to join a network. Wi-Fi uses the electromagnetic spectrum, part of the electromagnetic spectrum called radio waves. Usually the signals for Wi-Fi are transmitted around the 2.4 GHz and the 5 GHz wave bands. Each frequency is given a channel number for convenience. So if you look at this chart here, you can see this is the 2.4 GHz band, and you can see we've got a whole bunch of channels around here. And each channel operates at a certain frequency. So here, channel 4 is at 2.427 gigahertz. And each of these channels operates on a bandwidth of about 22 megahertz. So this is why we use channel numbers. Channel numbers are just more convenient than specifying the exact frequency. It's the same with TV channels, radio channels. You don't give the frequency, you give the channel. It's just easier. Signals transmitted on the 2.4 GHz frequency have a greater range but lower data transmission rates than those using the 5 GHz frequency. The 2.4 GHz frequency bandwidths are kind of an older system. 5 GHz has been introduced more recently. So older devices might only work at 2.4 GHz, whereas newer devices have a choice between swapping between 2.4 GHz and 5 GHz. So obviously in the former of these, you get the greater range, but in the latter, you get that greater bandwidth. You can transmit data more quickly. Obviously, in order to communicate, two devices must be transmitting and receiving on the same frequency. You don't have to worry about setting that yourself. Your Wi-Fi router, your mobile phone, or your laptop will talk to each other and they will agree which channel they should be using. They can also swap between different channels to make sure you minimize interference from other networks. That can be a problem. If you're operating at one frequency and your neighbor's operating at a very similar frequency or an overlapping frequency, this will cause interference and you'll have problems sending and receiving data. But as I say, modern Wi-Fi devices know enough to move between channels to make sure they minimize any of that interference. What are the advantages of Wi-Fi? Well, you've got cheaper setup costs. You need a wireless access point that connects to your network, and that's it. Anybody with a Wi-Fi device can then connect. So you also have less impact on the physical environment as you don't need to lay all these cables and drill all the holes in the walls, etc. You can connect lots of extra devices easily without any extra hardware. People can come in, and as long as they know your Wi-Fi password, they can connect to your network. Users, of course, can walk around freely and work in multiple locations around a building. No problem. It's also good for handling large numbers of users. Obviously, if you have too many users, you might have a fairly low amount of shared bandwidth each, but that's still more convenient than having to set up extra switches and extra cables for everybody to plug their devices into. Disadvantage: Wi-Fi tends to have slower data transfer speeds. Although modern wireless access points and wireless routers advertise very, very fast speeds, it's generally not as reliable as cabled, so you don't tend to get that full amount of speed in real life. Obviously, bandwidth is shared among connected devices. If you have lots of users at any one time, the bandwidth is less for everyone. The connection for Wi-Fi isn't as stable. You've got interference from other networks. You've got interference from walls and floors and building materials that happen to be in them. It's also less secure than a wired network, and it's more vulnerable to hacking. With a Wi-Fi connection, it's very important that you have encryption turned on. Otherwise, anybody can receive those packets of data because they're just broadcast in the air. So I think we've all experienced this. If you're next to the wireless access point, you get a really good signal strength as you move around the house or your office or your school. There are just some spots that always have a really bad or no connection whatsoever. Obviously, if you have a wired connection, you can avoid that problem because everywhere can have a good connection. Again, as I say, it's very easy to intercept wireless signals. So most wireless networks today are encrypted. And that means if you don't have the right password, you can't access the network. You can't send and receive data. When a device wants to connect to a secure wireless connection, a Wi-Fi password needs to be entered. I'm sure we're all used to doing this. Maybe at home you've got a wireless access point, a wireless router, and it'll have like the default security key on the bottom that you can type in. Of course, it would be better if you changed it to something else, but we use this security key to authenticate the device and allow it to connect to the wireless network. The Wi-Fi network then uses a unique encryption key to scramble the data that's sent over the network so that if it is intercepted, it doesn't make sense and cannot be used by others. Only devices with the correct encryption key can decrypt the data. So when we talk about an encrypted Wi-Fi connection, we're talking between your device or devices on your home or school network and transmission to the wireless router or wireless access point here. This is not talking about how you connect to the internet. It's just this leg that is encrypted here between your device and the wireless access point. If anybody tries to take the data from the air, it'll be gobbledygook, it'll be scrambled unless they know the security key. And it means other people can't access your network unless they have the key, because they won't have the key, they can't get access to it. However, if you're worried about a secure encrypted connection between your network at home and the internet, that's when we need to talk about HTTPS, Hypertext Transfer Protocol Secure, and things like that that we'll talk about in other lessons. There are many types of Wi-Fi encryption. The original one was called WEP, W-E-P. We've had WPA, WPA2, WPA3 is the latest. That was launched in about 2018. The first two, WEP and WPA1, are basically broken. There's always a race between hackers and people trying to secure networks. Older standards, there are vulnerabilities, or just computers are so powerful they can just crack those codes. So if you're looking at modern devices, WPA3 is the best to use at the moment. If you've got older devices, older routers, you might still be using WPA2, which is probably fine, but WPA3 as of the moment is the gold standard. Another type of wireless connection you can use is Bluetooth. Bluetooth is another form of wireless protocol that can be used over short distances using very ultra high frequency UHF radio waves, so ultra high frequency. It is very secure and does not require a clear line of sight between the two devices. Common use of Bluetooth are connecting your headphones to a device, streaming audio to Bluetooth speakers, and possibly sharing files between mobile devices. I'm sure you've all had a bit of experience with some of that. What are the advantages of Bluetooth? It's quick to pair. Data communication is more secure than an open, unencrypted Wi-Fi. Free to use if everything has Bluetooth installed. However, it only works over quite a short distance, usually just a few meters, and can be quite easily blocked by walls and things. And the bandwidth is lower than Wi-Fi, so you can't transmit as much data. So it's not suitable for every purpose. In summary, there are many different modes of connection: wired such as Ethernet and wireless such as Wi-Fi and Bluetooth. Wired connections offer faster, more stable connections, but wireless connections are more flexible, but tend to offer slower, less reliable connections with security of a bigger concern. I hope that was useful for you. I'll be back in another video next week. Good luck with your studies.